Isometric projections. Today we will discuss isometric projections. So till now we learned orthographic projections. In orthographic projections, we have learned projections of points, lines, planes, and solids. And orthographic projections of irregular solids also. Okay. In orthographic projections, there are front view, top view, and side view. But here, you will get only a single object. Isometric projection is a single diagram, or you can say it is a single object. There, you have three diagrams, like front view, top view, side view. I mean, there are different types of views, but here it is only a single diagram. In one diagram, we can know the length of the object, height of the object, and also width. All the dimensions we can know in one diagram. That is isometric projection. So before going to that isometric projection, just observe this diagram. Okay. So the angle is alpha. This is beta and gamma. There are three angles: alpha, beta, and gamma. Okay. So what is the total angle?
360 degrees.
Total angle is
360
360 degrees. So alpha plus beta plus gamma is equal to 360 degrees. So if you want alpha is equal to beta is equal to gamma, these three angles same, then what should be the angle?
120.
Angle should be
120.
So you can say alpha is equal, beta is equal, gamma is equal to 120 degrees. Okay? So all angles are same. That is iso. Iso means same. Next, metric means measurement. Same measurement, that is, you are taking the same angle. That is, alpha is equal, beta is equal, gamma is equal, 120 degrees. Now observe, here it is 120 degrees. Observe carefully. This is 120 degrees. Okay. Now I am drawing a horizontal line here. I am drawing a horizontal line. So this line is perpendicular to this line. Yes, sir?
Yes, sir.
This line is perpendicular to this line. So what is the angle here?
90.
90 degrees. Then what is the angle here?
30 degrees.
30 degrees. Right? Did you understand?
Yes, sir.
Total angle is 120. When you draw a horizontal line, this becomes 90 degrees. This is
30 degrees.
similarly left side also. Here it will be 30 degrees. Here it is 90 degrees. So in the orthographic projections, we take 30 degrees. For all the diagrams, we start with 30 degrees. By drawing a horizontal line, first we have to draw a horizontal line, then start with 30 degrees. Now I will complete this diagram, then you will understand. I will complete the diagram. I will close this diagram. Okay. So this is iso right. We call this as iso right. This is iso left, and this is iso top. So here, how to start this diagram? First, you have to draw a horizontal line. First, you have to draw a horizontal line. Then we have to take 30 degrees. Then we have to take 30 degrees. Why we are taking 30 degrees? Explain on it. This is because total angle is 120. When we draw a horizontal line, you will get only
30 degrees.
So then you will get iso right, iso left, and iso
Top.
This is the isometric projection of A cube is the isometric projection or isometric view of a cube. So this is only one object, one diagram. In this diagram, you are able to see the length of the object, you are able to see the height of the object, and also you are able to see the width of the object. Width. All the three dimensions you are able to see in one single diagram. Yes or no?
Yes, sir.
So that is isometric projection or isometric views. Okay? So we can pause here. Okay, this is the introduction. This is the introduction of isometric projections. So first we have to learn the isometric projections of planes like square, pentagon, hexagon, rectangle, circle or triangle also. First we will learn the isometric projections of the planes. Then we will learn the isometric projections of solids. Okay? So first one is we have to draw the
Square.
isometric projection of a square. First we will learn how to draw the isometric projection of a square. So how to draw the isometric projection of square, I will explain to you. First draw a horizontal line. First we have to draw a horizontal line. Okay. This is a three-dimensional object. Okay. This is a solid object. A solid object. Here you are able to see length, height, and width. But first we are learning the planes. In the planes it is again only two dimensions. Okay. Here mark a point. Draw a horizontal line. Mark a point, and then take 30 degrees and draw a line. And length of the line is say 40. The question is draw the isometric views of a square of side 40. So I am taking 40. Next, from here, listen carefully. From here, you have to draw a vertical line. Draw a vertical line. From this point, say this point is A, this point is B. From A you draw one vertical line. From B also you draw one vertical line. This is important. Next, join these two and name it as C and name this as D. This angle is 30 degrees. This is the isometric view of or isometric projection of a square. Main thing is this one, AD. This line should be vertical. Remember, this line should be vertical. This line is at an angle of 30 degrees. So for the same square, you can draw in some other way. Okay. You can draw the square in some other way. Draw a horizontal line. Mark a point. From this point, draw a line at an angle of 30 degrees towards the left side. Towards left. This is 30 degrees. And then from this point and this point, draw vertical lines. Remember, these two are vertical lines. These two are vertical lines. That is the main thing we need to remember in these diagrams. And naming, you have to name this as A, not this point as A. Because there are some advantages that we will know by drawing solids. Name this as A, name this as B, C. We are starting with this point, but naming is this one. So I will explain. Give the note. Suppose say this is a square. Where is A? So this is A. Listen carefully. This is A. This one is A, B, C, D. When I am taking towards the right, when I am drawing, this is right. What happens? A is here, B is going like this. A is here, B is going like this. Okay? But when I am drawing like this, A is coming this side. Did you understand?
Yes, sir.
Go on. This is A, this is B, C, D. When it is iso right, observe this point A. when it is A and B, you observe these 2 points. When it is iso right, it moves like this. B is this side, A is here. When it is iso left, what happens? Goes like this. A is here, B is here, A is here. Okay? So that is iso right and iso left. Next, in some other way, you can draw square. What is the some other way? What is that other way? What is the other way? Iso? Top. Iso right, iso left.
Isotop.
How to draw iso top?
30 degrees angle on both sides.
Okay, 30 degrees right side
30 degrees.
and 30 degrees left side. Both sides 30 degrees. This is 30 degrees, this is also 30 degrees. Okay? And next, name this point as A, this point as B. Next, we want C. To get C from point B, listen carefully. From point B, draw a line which is parallel to this line. From B, draw a line which is parallel to this line. Next, from here, you draw a line which is parallel to this line. Or name this as C. From C, you can draw a line which is parallel to AB. And name this as D. We will draw once again. This is A, this is B. From A, you draw another line, an angle of 30 degrees. Okay. Now this one looks better.
Yes, sir.
A, B, C. Both sides 30 degrees. Any doubt in this one? Iso right, iso left, right?
Isotop.
Is it clear?
Yes, sir.
And naming dimensions, how to show the dimensions. See, learn how to mark the dimensions. This is different. Extend the lines and draw a line which is parallel to this line. Which is parallel to this line. Mark this as 40. Okay. Similarly, for this diagram, you can show above, or I will show this side. What happens? For this line, just observe this line. How to mark the dimensions for this line. This is also important. Extend the lines, that's all. Extend the line. Extend the lines. This is different from orthographic projections. You have to observe this one. Just extend the lines. And here, you write 40. Suppose I want to show for this one. How to show? You extend these two lines. And draw a line which is parallel to this one. And then write the names as iso right, iso right, and this is iso left. This is
Isotop.
iso top. These are isometric projections of square. First we are running the planes, then we will go to solids. This is the isometric projection of square. Any doubts in this one? Is it clear? Yes, sir. Okay. You can pass.